Continuing on, there's a couple of special ones. The first one is the derivative of sine. And so if you're looking at the slope of the sine function, it's the cosine function. And so the trig functions are kind of nice that way. Although only the sines and cosines. It starts getting pretty nasty once you get into tangents and secants and that sort of thing. We'll cover that later. But right now, the derivative of sine is cosine, but the derivative of cosine is a negative sine, and then it cycles through in a group of 4. Okay, so you can just take the derivative right along. So the sine derivative of sine is cosine, derivative of cosine is negative sine. The derivative of negative sine is the negative derivative of sine, which is negative cosine. And so, and then you'd have the negative, or the derivative of negative cosine would be the negative of the derivative of cosine, which is the negative of sine, or back to the beginning as sine. All right, so the derivatives go like this. Sine, cosine, negative sine, negative cosine. Okay? And they just keep jumping. So until they get to the end, and then they come back up to the top. Like that. All right? Okay. So we're going to combine this with everything we've done at up to this point so that we can go ahead and put this all together into something we recognize. All right, now I'm going to start off with something that looks a little funky because I want to show you that it's really irrelevant what kind of variable you use. But you have in number 19, you have y is equal to pi over 2 cosine, or I'm sorry, pi over 2 sine theta minus cosine theta. Okay, now the derivative, if we take the derivative and say dy, we are not taking the derivative with respect to x. There's no x. In this case, theta is the variable, and so it's d theta, dy d theta. So dy d theta is equal to pi over 2 is a constant, so we can take that out. The derivative of sine is cosine. So it's pi over 2 cosine theta. Now, minus the derivative of cosine theta. The derivative of cosine of theta is negative sine of theta. Subtracting a negative, we add sine of theta. Okay, so that incorporated your sum, your constant, and your trig functions for derivatives. Let's take a look at another one, like number 23. Let's take a look at 24. I like 24 better. Okay, 24. 23 will kind of work the same way. But 24 says we're dealing with y is equal to 5 divided by the quantity 2x raised to the third plus 2 cosine of x. Okay, now here's something we haven't really discussed before. We have a thing inside. Now before you go off and start trying to work on this, it is not going to work the way that you think it might. There's a special rule that we're going to learn here in a couple of sections called the chain rule that will help us deal with things like this. Right now, though, we can distribute that power of 3 so that we have y is equal to 5 over 8x cubed plus 2 cosine x, so that when we take the derivative, y prime, we are going to take 5/8 times the derivative with respect to x of x to the negative 3. Remember, we've got to get that x back up on top. Plus 2 times the derivative of cosine x. In that case, y prime is equal to 5/8. The derivative of x to the negative third is 5/8 times negative 3x to the negative 4. We're bringing this down, and then we're taking one off. Plus 2, the derivative of cosine is negative sine of x. Recall that from up here. The derivative of cosine is negative sine. Okay. So now just cleaning this up a little bit, we have y prime then is equal to negative 3 times 5 is negative 15 over 8. But the x is still on the bottom, and so that's x to the 4th on the bottom. Minus 2 sine x. And there we are there.